Have you ever wondered how an AI can know all about your company's private docs without you having to ship all that sensitive data to the cloud? Well, today we're pulling back the curtain on the architecture that makes it happen. Retrieval Augmented Generation, or RAG for short. We're going to break down the entire stack, piece by piece, so you can see how it really works. Let's dive in. You know, this slide really gets to the heart of the problem for so many developers and businesses. You've got these incredibly powerful large language models, right? But all your valuable proprietary information, your internal wikis, your customer data, all your design docs, it's all locked away. So the billion-dollar question is, how do you get an LLM to understand your world without sending your most sensitive data out to some external service? And the answer, of course, is RAG. The whole concept is actually surprisingly elegant. See, instead of the LLM just guessing based on its huge generic training data, a RAG system first retrieves specific relevant facts from your private knowledge base. Then it augments your question with this fresh context. It's basically saying, hey, LLM, answer this question, but use these specific facts to do it. This grounding in real data is what makes the answer so much more accurate, and, crucially, it slashes the chances of the model just making things up, hallucinating. Okay, so to really get a handle on RAG, let's stop thinking about it as some kind of AI magic. Let's start seeing it for what it truly is, an engineering pipeline. It's a deterministic, predictable flow of data, and we're about to map out every single step. This right here is the core engine of any RAG system. It's got this simple 3-beat rhythm. First up, retrieve. The system acts like a hyper-fast research assistant, zipping through your knowledge base to find the most relevant snippets. Second, augment. It takes those snippets and injects them directly into the prompt. This is the key step. It's like giving the LLM an open book test with all the answers sitting right there. And finally, generate. The LLM crafts its response, but now it's grounded in the precise factual context you just gave it. And look, this isn't just some academic exercise. This quote from a developer on Reddit just sums up the real-world pressure perfectly. Companies want to build their own AI assistants using their own internal knowledge, but they've got a non-negotiable requirement: 0 external API calls. Privacy is everything. This is exactly the problem that RAG is built to solve. So, we have our 3-step pipeline. But what's the conductor of this orchestra? What's the brain that tells the retriever to go fetch, the augmenter to assemble the prompt, and the generator to actually talk? Well, that's the job of the orchestration layer. You can think of it as the central nervous system for the entire RAG stack. Now, in the orchestration world, 2 names really dominate: Langchain and Llama Index. A simple way to think about them is this. Langchain is your go-to for building complex, multi-step workflows. If the user asks this, then go fetch data, then call that tool, and so on. Llama Index, on the other hand, is laser-focused on the data pipeline itself, making it incredibly efficient to load, index, and query your information. They are the control plane that runs the whole RAG logic. All right, let's zoom in on that critical first step, retrieve. For a quick prototype, sure, a basic vector search might get you by. But in a real production application, retrieval has to be lightning fast and dead-on accurate. I mean, if you pull the wrong information, or it just takes too long to find it, the whole system just falls apart. This is exactly where a dedicated retrieval engine like Meilisearch becomes absolutely essential. It's built for one job: finding the right data and finding it fast. Features like hybrid search are a total game changer. They combine the precision of old-school keyword search with the semantic, meaning-based understanding of vector search. It's typo-tolerant because, your users aren't always going to be perfect. And those custom ranking roles, they give you the power to tell the system, hey, for this kind of query, these documents are way more important. And when we say fast, we really mean it. The industry benchmark for a production-grade retrieval engine is a query latency under 100 milliseconds. That's the speed you need for a real-time conversational experience. Any slower than that, and the whole application just feels sluggish. Another really interesting specialized engine is RAGflow. It excels at handling messy, complex documents. Its whole specialty is deep document understanding. So instead of just naively splitting a PDF into random chunks and hoping for the best, it uses intelligent template-based chunking to preserve the structure and the meaning of things like tables, lists, and sections. This means the context it retrieves is way more coherent and a lot more useful. Okay, so we have our pipeline, we have our orchestrator, and we have a super fast retrieval engine. But we still have that nagging privacy concern from the beginning, right? How do we make absolutely sure our data never, ever leaves our control?
Well, this brings us to the very foundation of the stack, the component that lets the entire system run on our own hardware. The ultimate goal is to achieve this, a completely self-contained system. Your documents, your vector database, your retrieval engine, and yes, even the LLM itself, all running locally, safely behind your corporate firewall. This is how you guarantee 100% that your data never touches an external API.
And the tool that makes this whole local-first approach not just possible, but actually pretty straightforward is Ollama. It's an incredibly useful piece of software that just simplifies running powerful open-source models like Llama 3 right on your own machine. It handles all the messy stuff, downloading model weights, managing configurations, and packaging everything up so you can get a model running with a single command. And honestly, the process is this simple. You run Ollama poll to download the model you want, and then Ollama run to start chatting with it. This completely demystifies self-hosting. I mean, in just a few minutes, you can have a state-of-the-art language model running on your own laptop. It's pretty amazing. All right, we've looked at all the individual components. We've seen the pipeline, the orchestrator, the retrieval engine, and the local LLM. Now, let's bring them all together and see the complete integrated architecture of a modern self-hosted RAG stack. Okay, let's trace the complete data flow here. A user prompt comes in and it hits the orchestrator. The orchestrator immediately pings the retrieval engine, telling it to search the vector database, which is just a specialized database that stores our documents in a way that's easy to search by meaning. The best matching context is retrieved and packaged up with the original prompt. This whole combined package is then sent to our local LLM, running through Ollama. Finally, the LLM generates a response, and the whole process completes securely on our own hardware. So, as you can see, the tools to build these powerful private RAG systems are not only here, they're maturing really, really fast. And that leaves us with a final question to think about. As the technical deployment part becomes more of a solved problem, what's the next major bottleneck for enterprise AI? Is it going to be the quality and the cleanliness of our internal data? Or maybe the difficulty of just evaluating if these systems are even working well? Or will another challenge pop up entirely? Something to chew on. Thanks for watching.